One of the key challenges when it comes to deploying mobile networks and indeed other wireless technologies within dense built-up environments is the ability of solid objects such as buildings, for example, to attenuate the radio signal, so to reduce the strength of the radio signal, and this will naturally have an impact on coverage. These buildings can also have impacts in other ways, so the radio signal can often be bounced off the solid objects such as buildings, for example, and of course this leads to a degradation in the signal quality itself. Now, one of the ways that we can mitigate this problem is through the use of something called RIS, or Reconfigurable Intelligent Surfaces. Now, you may also see these referred to as Reconfigurable Intelligent Reflective Surfaces or simply Reflective Intelligent Surfaces, but despite the differences in name, the principle itself remains the same. So we place a reflective surface in between the transmitter and receiver, and we will do that in a strategic manner to ensure that potentially large obstacles can be avoided, and it gives us a degree of control over the radio signal. So whereas in the past we would simply have had to accept that this was going to happen, well actually with a RIS or Reconfigurable Intelligent Surface, we can actually alter the characteristics of that radio wave. We can potentially, for want of a better word, we can steer that radio wave around a large obstacle such as a building, for example, and thus improving coverage. Now, what we can also do, depending on the type of RIS that we deploy, is we can essentially amplify, so that incoming impinging radio signal that is received by the RIS itself, but we can actually amplify, re-amplify that signal, as well as altering other characteristics. And the way that these systems work is they're essentially an array of potentially antenna components, of meta surfaces. We won't go into the technical details, but ultimately this is about being able to control and redirect incoming radio waves. Now, there are a number of factors that influence the type of reconfigurable intelligent surface that may be in use within a network. So we may need to consider factors such as power consumption, for example. So we have active systems which will require some form of power supply. Now, the benefit of using an active RIS is that we can essentially amplify that incoming signal, which wouldn't be the case in a passive system. So whilst both systems have the benefit of being able to redirect, to reflect the incoming radio waves, to alter the path of the radio signal, in an active configuration, we're also able to effectively re-amplify the signal. Now, the drawback of this is that we're going to see increased power consumption, and these surfaces themselves are going to be more expensive to deploy. Whereas with a passive system, not only are we reducing power consumption, and indeed we may effectively reduce power consumption to zero or a neutral power consumption, since we're actually able to harvest energy sources. We can even utilize the actual radio wave itself. So whilst we have more capabilities with an active system, actually in many cases the passive system may be absolutely sufficient and also represents a fairly low cost, energy efficient and simple solution to deploy. Now, of course, with many of the systems that we look at, often we see a hybrid approach in use. So there may be reconfigurable intelligent surfaces that may be produced that actually employ a hybrid approach, in that they're actually a mix of both passive and active approaches. And as I say, ultimately the choice of method to use here will be dependent on a number of factors, and also the conditions. So the environment itself will be a factor in terms of determining which approach will be the most appropriate. So in summary then, reconfigurable intelligent surfaces offer us a way of mitigating some of the attenuation that we might encounter as radio waves are absorbed through buildings, for example, or reflected by buildings, and gives us a greater degree of control, and thus we can provide a greater degree of coverage to the end user.